Here's a breakdown of motor starter sizing, full wave rectifiers, control circuits, and fastener standards. For a 10 horsepower, 480 volts alternating current motor, determining the correct component sizes is critical for safety and proper operation. The motor starter, responsible for safely starting and stopping the motor, should be sized appropriately. A 35 amp starter is a suitable choice for a 10 horsepower, 480 volts alternating current motor. The breaker, or circuit breaker, provides overcurrent protection. A 25 amps breaker offers a margin of safety, allowing for the motor's inrush current during startup without nuisance tripping, while still protecting against sustained overloads. The conductor, or wire, carries the electrical current to the motor. Using number 10 American wire gauge conductors is appropriate for a 10 horsepower, 480 volts alternating current motor, taking into account ampacity and voltage drop. Consult applicable electrical codes, such as the National Electrical Code, to ensure the chosen conductor is rated for the motor's full load amps. The conduit, which protects the conductors, should be sized to accommodate the wires with adequate space for heat dissipation and future modifications. A 1-inch electrical metallic tubing, or IMT, conduit is recommended to comfortably house the number 10 American wire gauge conductors. Moving on to full-wave rectifiers. A full-wave rectifier is an electronic circuit that converts an alternating current, or alternating current signal into a direct current, or direct current signal. Unlike half-wave rectifiers, a full-wave rectifier utilizes both the positive and negative halves of the alternating current waveform. This results in a more efficient and smoother direct current output. Typically, a full-wave rectifier employs a bridge configuration consisting of 4 diodes. During the positive half cycle of the alternating current input, 2 of the diodes conduct, allowing current to flow through the load in a specific direction. During the negative half cycle, the other 2 diodes conduct, ensuring current flow through the load in the same direction as before. This ensures that both halves of the alternating current waveform contribute to the direct current output. Now, let's discuss a 3-wire start-stop control circuit with a 110 volts control voltage. A 3-wire control circuit provides maintained start-stop functionality for a motor or other electrical equipment. It typically includes a start button, a stop button, and a holding contact from the motor starter. When the start button is pressed, it energizes the motor starter coil. The motor starter then closes its main contacts, supplying power to the motor. Simultaneously, an auxiliary contact on the motor starter, known as a holding contact, closes and maintains the circuit even after the start button is released. Pressing the stop button interrupts the circuit, de-energizing the motor starter coil. This opens the main contacts, stopping the motor, and also opens the holding contact, breaking the circuit and preventing the motor from restarting until the start button is pressed again. The 110 volts control voltage refers to the voltage used to energize the motor starter coil and operate the control circuit. Finally, SAE on nuts and bolts stands for Society of Automotive Engineers. The SAE is a standards organization that develops and publishes technical standards for engineering professionals in various industries, including the automotive industry. When you see SAE on a nut or bolt, it indicates that the fastener conforms to SAE standards for dimensions, materials, and performance. SAE standards are commonly used in automotive applications, but also find use in other industries where specific strength and quality requirements are needed for fasteners.